Hello everyone, welcome back. In previous videos, we have just go over the concept and the metrics, the collectors, and the Prometheus, Grafana's introduction in previous videos. So in this video, we're gonna go through the YAML files and also the scripts that help us to deploy the Kubernetes cluster on our local machine and also install the corresponding matrix clusters and the Prometheus and Grafana's to the cluster. So let's begin with that. And let's first take a look at the structure of the project. And it is constructed by the scripts and manifest, and also the design documentations. Recently I also implemented a GitHub Actions, the CI pipelines, and instead of that, we just execute the command and do all the things we do locally to make sure everything goes right, and also add some validations, check out whether the cluster and the nodes and the pods are in healthy status. So this is something about the GitHub pipeline. And under the design documentations, I plan to write, because we need to add a lot of indicators to show different layers of the Kubernetes healthy status. And so I plan to write a design documentation about to introduce the indicators of the metrics and why we add those indicators, and what status or what kind of information it can provide us to let us understand or get information of the status that the Kubernetes different components is in. So this is something about the design documentation. I haven't finished this one, so I do not plan to show it in this video. And to the manifest, we have different components or different matrix collectors installation YAML files, and we can go over to the scripts. And I take this one as the entry point if you want to deploy your Kubernetes cluster on your local machine. And I suggest you to begin your journey at this script. And this script is the all the things. It just construct all the things and be the entry point of the complete project. So let's begin with this script. At the beginning of the script, I just declare the cluster name, and you can do some modification to rename the cluster that you're going to create on your local machine. And if you haven't watched the videos that I published at the beginning of this series of videos, I highly suggest you to review the first video, which will take you about 5 minutes to learn what kind of tools you need to install. Like you need to prepare your Docker desktop to make your Docker desktop connect to the remote repositories and can pull some images from the Docker Hub. And this is the prerequisite condition one. And you also need to install the kind. Kind is a tool and introduced in that video too. And we use the kind this tool to create our cluster. And actually, it is the running inside of the Docker containers and to create a Kubernetes cluster. I have to say that even though it is not a totally native setup Kubernetes cluster, but it can just provide you the context just the same as the Kubernetes cluster on the product environment. So let's come back to the script. And after we declare those two variables, and we can execute the kind command. The kind command will create a cluster that was the name passing by this variable. And then it also pointed to another configuration file which defines some configuration parameters citing to the kind. So let's take a look at this configuration file. And inside of that, we just declare, suppose we're going to set up a Kubernetes cluster, it should have different components, and like the master node, worker node, and on the master node side, the API server, etcd, and a lot of other components. We just doing some modifications of the IP address and doing some authorizations mode, and also some role some configurations added to the node layers component. Then come back to the shell script. And after we execute this command, we just wait for about 3 minutes. The cluster will be established, and we're just waiting for the worker nodes are set up too, and like the worker nodes join the cluster. So we wait out the node conditions becomes ready, and then we continue to execute the two commands, get nodes, get pods, and echo a message to show that current context the cluster is already set up. Then we change our directories to the name path. And the next step, we're going to create a namespace. Here is a namespace. Because this is around the topic of the metrics with the pillars that construct the observability, so I named the namespace as the metrics. After we create the namespace, and we just the first components we establish is the metrics collectors, trying to collect operating systems metrics, CPU memory usage, and the metrics from that layer by establishing a node exporter. The node exporter is constructed by two YAML files. The first one is it is set up not a single pod, it's set up as a demo site. And to make sure that the demo site can be get accessed by other components in the cluster, and we attach a service to the demo site so that the node exporters, the endpoint exposed metrics data can be subscribed by the premises. So let's take a look at the node exporter. It is in this folder. Well, the RBAC, because the node exporter is underlying close to the operating system layers, and the RBAC actually just do not work. The RBAC is a layer associated with the namespace. It's a much higher layer. So the rows, row bandings, and the service account do not affect the specific operations we do to the node layer, to the operating system layer. So it just occupy the position, and actually we do not need to allocate the rows to the demo site. And here's the demo side of the node exporter, and we just set several labels, and the template is declared here. And under the template, we also have the specifications of the containers. And this container's name is called the node exporter, and it uses the image's name and passing the parameters. And once we set up the container, and we just like the login users to have such kind of permissions to do some operations inside of the container, and also the parts. And here is the service attached to the node exporter, and it didn't declare the type of the service, so its default is the in type of the cluster IP. And inside of the cluster IP, the other pods and belongs to the other component where replica set can get access to the node exporter through this port. So this is all the things about the node exporter. And let's continue. Check the installations script. And the next one is the C advisor. C advisor will provide us the merging status, especially for the containers, which means that it can provide the specific containers running in the Kubernetes system corresponding magic data, CPU usage, and whether it is out of the limit of the usage, and also the memory usage and kind of stuff. Here is the advisors YAML files, similar as the node exporter. And the node exporter and the C advisors are very under layers of the Kubernetes cluster, so the RBAC will not work too. We use the security context to allocate the corresponding permissions to the users who log into the containers. And this is the demo site. Inside of the demo site, we just add a lot of selectors and labels, and under the template, we also have the containers declarations, and it use the message, and also expose the port, and a lot of volume mount are mount in the container, and the name of the containers is also the C advisor. And this is the service of the advisor, and the type of the service is also the cluster IP. So this is something about the C advisor. After we install the node exporter and the C advisor tool of the node layers, the matrix collector, we go forward to the KMS, which is a cube state matrix. And cube state matrix is the more upper layers matrix collector. So we need to declare the RBACs to allocate the corresponding actions to allow the KMS to do some operations in the context of the cluster. And let's take a look at this KMS RBAC first. So in this RBAC YAML file, we first create instances of the service account with the name of the cube state matrix in the namespace of the matrix too, and add the labels. And then we create a cluster role. Cluster role can allocated role, not limited by specific namespace. And the cluster role is also with the name of this cube state matrix. And in the API roles, it is allowed to do the operations like the list, watch, pause service, and the other event, this kind of stuff is allowed by this cluster role. And in the API groups of the APPs, it can also list and watch the deployment, demo site, and the replica sets, stateful sets. And in the batch API groups, the drops and cron drops are allowed to execute the operations of the list and watch. And here, we create a class role banding to connect the service account. The service account is just like a user ID, and which allow the service account to do the following operations to the operations and to the specific objects across the cluster. This is something about the RBACs of the KSM. And let's go forward to the deployment. In the deployment, we also add a lot of labels to the deployment. And deployment labels help the template created pods to be selected and joined to the deployment site. And according to this parameter, we only create one replica. And instead of a replica, we create a pod. Inside of a pod, only have one container that download the Docker images here and expose the two ports. One is for the HTTP metrics, and the other one is for the telemetry. And these two ports will expose the metrics endpoint to like the Prometheus to consume the metrics data here. And we also have a liveness probe. It's just like the Heartbeat endpoint. And this like to say that when I set up a container instead of the pod by using these Docker images, and once the container is set up, I will keep and I will wait for 30 minutes and continue send request for every 30 minutes to send the endpoint of the health and to check out whether this endpoint can give me some responding data. And the responding data will show this endpoint or this container's the liveness status. It's just like the Heartbeat checking. So this is something about the cube state metrics. And let's come back to the shell script. So after we install 3 metrics collectors, we go forward to deploy the Prometheus. The Prometheus is constructed by 5, 1, 2, 3, 4, 5 components or the resources. The first one is RBACs, which allocate the corresponding roles that allow the Prometheus can do the corresponding the operations in the cluster or in the namespace. And we need to, we already talked about that Prometheus supports the TSDBs, which it can allow us to store the data set to the disk layers, like this one here. And we know that the pod is not very stable component running in the cluster, and it is minimum schedulable item. So there's some it can be destroyed because of some resources OOM or the memory resources OOM or other strategies made by the Kubernetes schedulers. So we still want our underlying data will not affected even though the pod of the Prometheus server running got destroyed, the underlying data will not be affected. So we create a PVC, which is the persistent volume claim, to bind to a piece of the disk. And so that even though the pod will be destroyed and restart, it can still get access to the history data that's stored by or wrapped by the PVC. So that is the reason why we created a PVC, to make it flexible used by the pod side. And the config map, let's take a look at the config map here. The config map is just like a key value store, only for provided the configuration data by configure the Prometheus server. Because we set up the Prometheus server, we usually setting the parameters to do some modification or configurations to the Prometheus server, like the which way we store the Prometheus data and the update status or refresh frequencies, and how many times and how many exporters it connected to. And different from loading the disk file directly from the disk layers, and we just load the configuration files into the memory, and this memory is wrapped up by the config map in the key value pairs. And as long as the deployment of the Prometheus is set up, it will try to set the configuration parameters it's required directly set from the memory that running in the Kubernetes system. This is the config map. And we also want our setup Prometheus be get access to from either the browser side and be can communicate with other components to set the metrics data, just like this diagram. It can communicate to the applications or other metrics collectors of the Kubernetes cluster. So we need to make it available in the cluster scoped network. So that is why we declare the service here. And the type of the service is node port, so that we can get access to the Prometheus UI page directly from the browsers. So that is why we declare it as the node port. The static allocate the port can be get access to from the external world of the Kubernetes cluster. So after we deploy all of those, we continue to deploy the last component or the last tool that constructs a metrics ecosystem. It is a Grafana. And the metrics, the collectors collect the metrics data and store and can be queried from the Prometheus, and query the metrics data can be shown on the dashboard with the help of the Grafana. And it's just the same deployment as the Prometheus. And but to the Grafana, I do not need a config map. It's just constructed by the RBAC to allocate the roles and permissions, and to allow the Grafana to doing some cluster scoped operations like the get polls and list polls or get deployments, this kind of stuff. And the Grafana also have a storage layer to store the dashboard into some files. And we don't want the Grafana's the pod destroyed together with the underlying consistent files destroyed too. So we also need to create a persistent value claim to bind to a piece of the disk resources. So even though the Grafana's pod is got destroyed and its history data are still available, and it is also deployed by using the deployment, and we can set the replica numbers here. And we also want our Grafana's web UIs be available. Take this as an example. So in the service demo file, we also set the type of service as the node port so that it can get access to from the external world. For example, browsers can get access to the web UI. So that's all the steps for now. We have, if we execute this shell script, we have established a Kubernetes cluster and also install the merge selectors, create the merge namespace, and install the Prometheus and Grafana. And here, to the line of the 61 are the healthy checks. In the healthy checks, we just ran the script to check the healthy status, to check whether the Kubernetes cluster is in its healthy status. Let's take a look at this script file. It's just the implement. It's just the, let me think, take a look at this one. Yeah, this is the component that we want to check whether all the components running in the current context. And we just execute the command in the namespace of the kube system and to traverse each of the components are exist and trying to find by using the JSON pods to set the specific status to check out whether the pod of each of the components. So it is divided into two steps. In the first step, we just traverse the keywords and using this command to get the specific pod name because this is a keyword, and when it is running as a pod in the kube system, it has some suffix. And here we just trying to check, retrieve the specific pod name of the kube API server, and then after we get the pod name and we trying to execute this JSON pods to fetch this pod specific phase and the status, the internal inside of the pod container status is healthy or not, and doing some validations to make sure every component, every pod and the containers in the kube system works fine. And after we do that, this is always timeout, so I choose to comment it. And after all the things are set up, we can do some port forward so that our setup Prometheus and Grafana can get access to in our browser. So I think this is all the things I want to introduce in this video. And in our next video, we will directly run our script to set all the components, include the Kubernetes cluster and the components we want to deploy to the Kubernetes cluster, and just by using this script. And this is the entry point of all the stuff's installation. So I think this is the end of our recording, and see you in the next one.